In this lesson, we're going to be talking about how to compare and order rational numbers. Rational numbers are numbers that can be made into fractions. So the rational numbers that we're going to be looking at are in this category right here. They are positive and negative fractions, decimals, percentages, and those are the numbers that we're going to be looking at. Let's go ahead and see if we can compare these rational numbers. So the directions say fill in the blanks with greater than, less than, or equal to. Let's look at this first example, 2/3 and 5/8. You can see that we have two fractions. Now you might have those two fractions memorized, but if you don't, you have to know what the decimal is of each one of those fractions. So in order to do that, we're going to actually do the division. So 2 divided by 3. Here's how you do this. 3 does not go into 2, meaning we need to put a decimal here and here. Let's go ahead and add a 0. 3 goes into 20 6 times. So I'm going to go ahead and put a 6 up at the top. 6 times 3 gives us 18. So I'm going to do my subtraction. 20 minus 18 is 2. 3 does not go into that 2. So I'm going to add a 0 and I'm going to carry it down and gives us a 20. 3 goes into 20, again, 6 times. You might be saying, well, there's a pattern going on here, right? And you're exactly right. So therefore, the decimal 2/3 is actually going to be 0.66 or 66 hundredths. Let's go ahead and do the next one, 5/8. Let's go ahead and divide 5 by 8. 8 does not go into 5, so we're going to have to go ahead and add a 0. So I'm going to add a decimal, and I'm going to add a 0. All right. 8 goes into 5 6 times. So 6 times 8 is 48. 8 does not go into 2, so I'm going to bring down a 0. 8 goes into 20 2 times. 2 times 8 is 16. 20 minus 16 is 4. I'm going to bring down my 0. 8 goes into 40 5 times. So we can actually stop right there. So we have 0.625. So there are the decimals made up of these fractions. And you can see that 0.66 is a bigger number than 0.625. So I'm going to put the greater than symbol in the blank. All right, the next one, you can see that we're actually already given decimals, so we don't need to convert anything. We have to know which one's bigger. Well, you can see the one that on the right-hand side that has 2 digits here. This is actually the number 3 thousandths. So if I were to write this as a fraction, it would look like this. 3 1,000ths versus this one, which would be 3 100ths. So obviously you can see that 3 100ths is a bigger number than this teeny tiny 3 1,000. So I'm going to go ahead and put the greater than symbol there. All right, 3/8 and 40%. So 3/8 you might know off the top of your head, but if you don't, you can go ahead and do the division. So I have 3 divided by 8. I'm going to add my decimal, and 8's going to go into 33 times. 3 times 8 is 24. Bring down the 6. Bring down a 0. 8 goes into 60 7 times. That's going to be 56. I'm running out of room. Sorry about that. 0. 8 goes into 40 5 times. So my decimal is going to be 0.375. Now over here, 40%, if you remember, when we convert percentages into decimals, I have a percent, or I have the decimal right next to the percent. I'm going to move it 2 spaces to the left, giving me 0.40 or 0.4. You can see that that 40% is going to be larger, is going to be larger than the other number. So I'm going to go ahead and put a less than symbol. All right, moving right along, we have 2 decimals now, -7.8 and -7.82. Now, you have to remember a number line. Remember, it's going to look something like this, -1, -2, -3, and we're dealing with only the negative side. So when you're dealing with only the negative side, you can actually see that the number itself, like 4, looks like it's bigger than 3. So you have to take that into account. So this one, you can see -7.82 is actually going to be larger than -7.8, giving me the less than symbol. All right, 3/7. You might know that off of the top of your head, but again, if you don't, you can go ahead and do the long division. All right, 3 divided by 7. So I'm going to go ahead and add my 0. So 7 goes into 34 times. 4 times 7 is 28. I'm going to subtract it, give me 2. Go ahead and bring down my 0. 7 goes into 20 twice. That's going to be 14. And that's going to give me 6. I'm going to bring down my 0. 7 goes into 68 times. That's going to be 56. Which can be 4. And I can actually stop right there because look, I have a number here. It's going to be 0.428 and it's rounded to the thousandths place. The number over here on the right is also rounded to the thousandths place. So now I can look and see which one is bigger. Obviously 0.428 or 428 thousandths is going to be my larger number. So I'm going to put a greater than symbol. All right, the last one here, -7/10 and -4/5. So you might know 7/10 is just going to look like this, 0.7. And of course, it's going to have a negative next to it. And then here, -4/5. You might know that one off the top of your head as well. That's going to be 0.8 and it has a negative in front. You could also do the long division for these two as well. Now, if we ask ourselves which one is going to be larger, well, the one that has, you have to be thinking about the number line like back in this problem. So -0.7 is going to be larger than -0.8, which is going to be smaller. So we did a lot of comparing on that page. Now let's go ahead and see if we can order these rational numbers. I'm going to give you a little helpful tool here to help you. And it's this little chart that I've created. The directions say, fill in the chart below and follow these instructions. On line 2, write the number as a decimal. And then on line 3, rank them from least to greatest, 1 to 4. So you can see that in line 1, I'm given 4 rational numbers that I want to put in order from least to greatest. So let's go ahead and follow the directions. On line 2, let's just write the decimal number. So I can see that my 0.75 is actually already a decimal, so I'm going to just rewrite it. 9/2, you can go ahead and do the long division in that case here, which is going to be 4.5. 2/3 you might have memorized, but that's going to be 0.66 repeated. And 0.8%. Well, I'm going to go ahead and I'm going to move that 2 spaces away from the percentage to give me 0.008. So now I have my 4 numbers and I need to order them from least to greatest. So I can see that the number here is going to be my least, so I'm going to put a 1 there. My next number would be my 0.66 repeated. That's going to be my 2, my 3, and my 4 from least to greatest. Now, anytime you're doing a problem like this, you have to write the original numbers from line 1 in order from least to greatest. So let's go ahead and rewrite 0.8% is my smallest. Then 2/3 is my next smallest, or I guess my next largest. Then 0.75, and then 9 halves. Notice how I wrote those numbers in the original form that they were given in, not the decimal form that I put them into. And there we have ordered these from least to greatest. Let's take one more look at another one of these. Let's go ahead and fill in the chart the same way. Let's go ahead, 87%. I'm going to move the decimal over twice, and that's going to be 0.87. The next one is a fraction. So again, I could do that. I could do the long division if you don't know it off the top of your head. I'll go ahead and do it to show you this time. So 8 does not go into 7, so I'm going to add a 0. And that's going to be 8, so 64, 6. I could bring down my 0. You can see that 8 goes into 67 times. It's 56, 4, add my 0. And that's going to be 5. So that's going to be 0.875 is going to be my decimal. Now, 1 3/5. I know that the decimal is going to have a 1 and then a decimal. And then I have to think about, okay, 3/5. I could go ahead and do the long division here. And 3 divided by 5, I'm going to add my decimal, 0. 5 goes into 30 6 times. And actually, that gives me a remainder of 0. So it's just going to be 1.6. And then the last one, oh, I love these ones when they're already written in decimal form. Those are the best. Now that I have them all written in decimal form, let's go ahead and put them in least to greatest form. So my least number here, you can see it's going to be either of these two on the left side. And the least one is going to be the 0.87. So, oh, I didn't mean to write the number. I meant to write a 1 there. So let me go ahead and do that. So this is my least number, my second least number, my third least number, and then my fourth least number. So let's go ahead and write the originals on the line now. I first have 87%. Then I have 7/8. Then I have 1.53 or 1 53/100ths. And then I have 1 3/5. And that's a great little tool on ordering these from least to greatest. All right. I have 2 word problems now. And what we're going to be doing is comparing these rational numbers. So in the last 10 games, Mike made 7/12 of his free throws. For the same period of time, Cameron made 4/7 of his free throws. Which player had the better free throw record? So let's go ahead and look at Mike. Mike had 7/12. To compare these, we need to put them into decimal form. So 7/12. We have to do some division here. So let's do 7 divided by 12. 12 does not go into 7. So I'm going to go ahead and add my decimal, and I'm going to add a 0. 12 goes into 70 5 times. That's going to give me 60. It's going to give me 10. I'm going to go ahead and add a 0 there. 12 goes into 100 8 times. That's going to give me 96. I'm just doing the long division here. Carry down my 0. 12 goes into 40 3 times. And 12 times 3 is going to give me 36. Subtract. And you can see that it's actually going to start repeating here, right? So there's Mike's free throw. So it's 0.583. We'll just say repeated. Okay, that's Mike. Now let's go ahead and do Cameron. Cameron's is 4/7. This one might be a little bit easier to calculate. So 4/7. So here we go. 4 divided by 7. I'm going to start with my decimal. So 7 goes into 40 5 times. It's going to give me 35. And I'm going to subtract them. Bring down my 0. 7 goes into 50 7 times. It's 49. And you can actually see that I could literally just stop, couldn't I? I could just stop here because Cameron's is 0.571. And if I wanted to compare them, which one had the better percent of free throws, you can see that Mike's is a little bit bigger than Cameron's. So we'll say that Mike is greater than Cameron. So who had the better one? Well, Mike did. All right, the last one. On Monday, Rob averaged 3.75 laps per minute. On Tuesday, he averaged 3 4/5 laps per minute. On which day did Rob run faster? Well, it looks like on Monday, they already gave us the decimal, so that's going to be 3.75. But on Tuesday, they gave us a fraction. So on Tuesday, it's 3 4/5. So we know that this number is going to be 3 point something. So the 4/5 part is the part where you have to do the math. So 4 divided by 5. I'm going to go ahead and add my decimal. 5 goes into 40 8 times. Oh, that's awesome. Remainder 0. So it's going to be 3.8. So looking at these two, it's asking the average number of laps per minute. You can see that he's slightly bigger, has a bigger average on Tuesday than he does on Monday. Not by much, but it is, if you answer the question, on which day did Rob run faster? Well, he ran faster on Tuesday. All right, that brings us to the end of our lesson on comparing and ordering rational numbers.